Now we're going to apply Faraday's law to an electromagnetic wave. And we're going to use the result that we found for Ampere's law to the electromagnetic wave. So here we have the x-axis, z-axis, and y-axis. We have the electric field going. I would just put a quarter of the wave. So let's say something like this. This is the electric field, and the magnetic field goes here. Example like this. This is the magnetic field. So Faraday's law says that the closed loop integral of the electric field dot dl is equal to the negative of the change in magnetic flux with respect to time. So this is a induced EMF to the change in magnetic flux. So we need to choose a closed loop. So let me pick this one with the length L. Here I have the same loop. You mind that the dimensions are that I draw it to scale. So this length is L. So I will first calculate this part. So what is the magnetic flux first through this surface? So the magnetic flux is equal to the closed loop integral of the surface B dot dA. So for A infinitesimal dA, I have the length L in this direction, and this is C. Well, it supposedly goes parallel to this line. Should draw it maybe more like this. Well, so dA is equal to C to L dC. And what is B? Remember that B is defined as B, original B, times the cosine. You can use cosine or sine, whatever you want. I will use cosine of the wave number in the direction of propagation, so C, minus omega t. And in this case, B goes in the j direction, so j. And the electric field, remember that is the original electric field times the same thing, cosine omega c. In other videos, we will talk about more. Well, we talked about more about the equations of this. The electric field goes in the x direction, so like this. So I have B is equal to this. So I have that the magnetic flux. Well, magnetic flux is equal to the closed loop integral of B sub 0 cosine of omega of k c minus omega t dA, that is L d c, and this goes from 0 to lambda over 4. Here this is lambda over 4. Please, from here to here is lambda over 4. From here to here is lambda over 4. So I'm integrating with respect to dc, so I can take b0 and L out of the constant, out of the integration. So I have b sub 0 L times the integral of ks minus kc minus omega t. So this is integral of cosine would be sine of kc minus omega t divided by k, and this goes from 0 to lambda over 4. So I have I don't know if this still sees on the blackboard, or I think so. So the magnetic flux is equal to could be B L over K times, first I have sine of lambda over 4 times K minus omega t, and then minus sine of, here is 0, so I will just put of minus omega t. Remember that K, the wave number, is equal to 2 pi over lambda. So I have that the magnetic flux is equal to B L over K times the sine of, here I will put pi, 2 pi over, sorry, so lambda is 2 pi over K. So here I will put 2 pi over K, that will cancel, and I have sine of pi over 2. Sine of pi over 2. And here is a sine of negative something is the same as the negative of the sine of omega t, and times this negative, it makes it positive. So plus the, sorry, I forgot, minus omega t, and then plus sine of omega t. Remember that all this stuff, sine pi over 2 minus omega t, this is the same as cosine of omega t. So I have the magnetic flux is equal to BOL divided by K times the cosine of omega t plus the sine of omega t. So now I want to take the derivative of this, the time derivative of this, with respect to time. So this is B sub naught L divided by K times the derivative of cosine omega t is negative sine omega t. Derivative of sine omega t is positive cosine omega t. And now if I want to take the negative derivative, I switch signs, so it's negative here and the negative here. I could also change the signs here, and so I would have positive sine and the negative cosine. So positive sine, negative cosine. So this is the first part for Faraday's law. I will erase this part. Now we need to find the closed loop integral of E dot dl. So closed loop integral of E dot dl is the same as the integral of E here, because E is just propagating in the x direction or the I direction. In this part and this part, the electric field is perpendicular to L, and E is just 0 in this part. So we only care about this part and this part of the closed loop. So we just need to integrate from 0 to L of E dot dl. When E is, when we are taking here C equals lambda over 4, and the loop integral from L to 0 of E dot dl in this part that is when c equals 0. So now we have closed loop integral of E dot L is equal to, and this part is in these two, we're going to substitute with this E. So here we need to put in this C, we take lambda over 4 for this first part, and remember that K, lambda over 4 is the same as K times lambda is 2 pi over K, 2 pi over K divided by 4, so we just have pi over 2. So we have E naught, well, the integral from 0 to L of E naught cosine of pi over 2 minus omega t dl plus the integral from L to 0, of E naught, and this part, because c would be equal to 0, we cancel this part and we just have cosine of negative omega t dl. So this would be the same as the cosine of omega t. Cosine of theta is the same as cosine of negative theta. And I can take all this stuff out of the integral because I'm integrating with respect to L, and in any part of this I have L, so I can take everything out of the integrals and just left with the integral of 1. So I have that the closed loop integral of E dot L is equal to E naught cosine. This I believe is the same as sine omega t. Just let me quickly verify this because I always forgot if negative or positive, but a quick way to verify this is just remember that cosine of sum is cosine of pi over 2 cosine of negative omega theta minus sine pi over 2 sine negative omega theta. And let me verify this. So I have cosine of pi over 2 is 0, so all this goes to 0, and this is 1, and this is negative sine of omega t. So this negative and this negative makes it positive sine of omega t. Alright, so we have it. So this is E naught sine omega t from 0 to L dl. Here you can add a 1 if you want, plus E naught, this is just cosine of omega t from L to 0, 1 dl. This is the same as closed loop integral of E dot L is, this will be just E naught sine omega t times L. I will put the L here, and this is E naught cosine omega t, and this would be negative L. So negative L. So I have at the end that the closed loop integral of E dot L is equal to E naught L times the sine of omega t minus cosine of omega t.